Alright, so this is Steve Scully. I'm back with the instruction manual as is written in Cosmos. We're on chapter 5, section E, the cosmic microwave background. Perhaps the most referenced observation of the Big Bang model, even beyond redshift, is the cosmic microwave background. This is considered to be one of the, quote, pillars of the Big Bang, though it is not at the foundation, but is supplemental to redshift. The two observations did not occur simultaneously and lead to the model. Rather, redshift occurred and the model was made, and then the cosmic microwave background was later detected and taken as a pillar. As mentioned with the double slit experiment, one observation alone stands at the foundation of each model. The CMB, as shown in figure 32 below, is considered important to the Big Bang, however, because it is said to show the remnants of the Big Bang. While the Big Bang model has an extremely captivating explanation for this particular observation, it does not stand out as so important in the infinite universe model. As discussed, the universe is infinite, and therefore there are layer upon layer of ever smaller masses filling all of space, acting as the ether. The CMB is ultimately the baseline radiation from our surroundings that we are able to detect. It is extremely uniform, but this is what we would expect to see on large scales. Balance. Just because there is a generally low energy, generally uniform observation on the large scale does not mean there was an explosion that specifically produced the entire universe and we are looking at the remnants of that explosion. The leap is too far and built on many assumptions. Everything we see shows signs of uniformity, of balance, and so too does the CMB. Section F, Dark Energy. While previously expansion of space was shown to be arguably false, we stepped away from dark energy for a moment. Just as other observations, such as the CMB, build on previous observations and thereby require the interpretation of the previous observations in order to fit the model, in the same way is dark energy disproven when expansion of space is disproven. However, the infinite universe model can be applied to the observation just the same. As was previously discussed, we observed increasing redshift per distance in all directions. This is recognizably correlated and has come to be known, quote, Hubble's law. The correlation is considered linear and has been used to explain expansion of space, and the detected acceleration in the rate of redshift per distance over larger distances is claimed to be caused by, quote, dark energy. The correlation of Hubble's law was explained with the infinite universe model using gravitational redshift in a figure 8 orbital structure. The nature of the figure 8 orbital motion of light makes the particular case of the accelerating rate of redshift rather complex and nuanced because it requires a combination of gravitational redshift and gravitational lensing. When light is gravitationally redshifted, it becomes lower in density. As this occurs, these particles become smaller and travel faster. In a prism, when light passes through a prism, it is separated where red light is the least bent by the prism's effects on visible light. This is directly because the particles of red light travel sufficiently faster so as to pass the interface more quickly, and so they are not influenced by the local gravity, alike to the double slit experiment, as much as the heavier but slower higher energy violet light. In a similar way, when the light is redshifted across large distances, it drops in energy substantially enough where the actual figure 8 structure is modified. This is where it gets trickiest. There's something about the change in the overall size of the figure 8 that leads to increasing rate of redshift per distance. The best analysis for this would be to look at how an electromagnetic field is formed because the flow pattern of the light would be the same as shown in figure 33. So in a reduced redshift, it would have a smaller figure 8 structure, and as it redshifts, it's not as capable to be lensed, and so it leads to a larger figure 8 in essence. And the question then is, how does this larger figure 8 produce more redshift per distance? As light redshifts, it travels radially outward further due to the lesser capacity of it being lensed at lower energies. However, it also has an increase in the distance of the orbital motion, which is the portion of the motion of the light in the figure 8 orbital where additive redshift per distance actually arises. Radial motion cancels with itself. It is firstly proposed that this is sufficient to cause greater overall redshift per distance even at lower overall gravitational forces during each larger figure 8 orbital. Also, the environment is lower energetically further from the central mass. Precisely how this combination causes redshift per distance to accelerate rather than to decelerate appears to be a result of how these variables interact with one another. In the past, I would have said that this acceleration was caused by the radial distance decreasing as it redshifts, causing the light to orbit closer and closer. This interpretation would lead to an increasing gravitational force throughout the orbital, which seemingly would increase the rate of redshift per distance. However, this was prior to holding the prism's results to be evidence. It would be the opposite. Higher redshifts would make the light be lensed less, not more. At that time, I thought the speed of light was constant. This was before I realized how gravity was caused by particles traveling at a velocity approaching infinite. In short, the observation involves many systems functioning over a very long period of time and over extremely large distances. Regarding this observation, I presently can only with good confidence propose that the accelerating rate of redshift per distance at large distances results from a change to the environment due to the orbital distance of the light being at a greater distance from the central mass and from an increase in distance of the orbital motion that offsets the lower gravitational influence. At greater distances away, there is also a lower energy density. As a result, the light could be less balanced with the environment and thereby be stripped of more energy by a lower energy density region than at smaller radial distances from the central object, where there are relatively higher energy densities, causing a detectable overall increase in the rate of redshift per distance. So in other words, if this is that central object and the figure 8 is small, then the energy density of basically the radiation from this object is high nearby. And so when light is physically traveling through that density, just like if it were to be passing through a high temperature area, it would not have as much of its temperature stripped away as if it's traveling through a cold temperature area. So further away, it's lower in energy. And so when even though it's not as influenced by gravity when it orbits, so the force of gravity is lower, the distance allows for lower energy density around the particles, and so it strips more energy per distance from the light as it travels, leading to an observance of an accelerating rate of redshift per distance. Okay, so the last section here of this chapter, section G, plate tectonics and the expanding Earth. For over a century, the hypothesis that the Earth has undergone physical expansion and grown from a previously smaller radius has been one of the most well-known proposals for the formation of the continents as we see them today in what has been known as the expanding Earth theory or the growing Earth theory. This is largely due to the apparent ability for all the continents of Earth to generally fit together rather nicely without oceans on a smaller globe. More recently, this model has been largely abandoned by the scientific community in favor of plate tectonics, with such explanations as the Earth is not presently expanding. The present theory of plate tectonics suggests that the continents are located on plates which physically slide around relative to one another, and across millions of years they have moved from a single landmass where all the continents were together, known as Pangaea, to their current positions. The critical difference with Pangaea and the expanding Earth model is that Pangaea was said to still have a single large ocean. If we think about this from an intuitive standpoint, the concept that the Earth would form with one single ocean that was opposite to one single landmass composed of several plates is rather far-fetched. A giant island of all continents. Gravity suggests there would be a more distributed formation. On the other hand, if the land masses do fit together into a single smaller surface of a globe without the oceans, then regardless of our lack of understanding for how the Earth changed to its present state, this is strong evidence that this was the case. Science is about answers. If we do not have an answer for a question within a model based in logic and reason, people will develop new explanations entirely for the observed phenomena. This has occurred several times, as this book has discussed, in models of the universe which have dismissed a careful, logical, and reasonable approach due to lack of having an answer within the model now. In the case of the expanding Earth, the problem that arose from the model was the question of how did the Earth expand. Proponents of the expanding Earth looked at the evidence that it expanded, which does in fact exist, and stood behind the interpretation that the continents were once a single landmass with no oceans on a smaller globe. What they could not answer, though, was how the Earth had grown. What was the mechanism? As a result, alternative proposals were made where the model did not include this feature. Plate tectonics supplanted the expanding Earth model and has become all but labeled as fact. Still recognized as a theory in the same way as the Big Bang, general relativity, and quantum mechanics are each labeled as, quote, theories. Actions show them to be believed with absolute certainty. So too is the theory of plate tectonics. The strongest argument that plate tectonics had against the expanding Earth theory was literally how. This is not a disproof, and the evidence in favor of the expanding Earth model still is just as thorough as plate tectonics. With that in mind, the infinite universe model explains how a planet expands. The Earth's electromagnetic field is composed of particles which physically travel in generally figure-8 shaped orbitals. This is strongly influenced by the physical rotation of the planet. These particles all pass through the center of gravity of the Earth. As a result, the center becomes an area of high density of these particles where they are more likely to interact and become larger systems through fusion. Atoms are created as a result of this process. If the system is already in equilibrium, it will remain essentially the same. However, if the system went through a change, such as going from a non-rotating, like to Venus, to rotating, like Earth, then the newly formed electromagnetic field, due to the rotation, will lead to creation of mass that is greater than the loss of mass, and so the body would grow in mass, creating particularly lower molecular weight particles. As the rotation would also bulge the equator of the body, it would produce stress on the single landmass that would be exacerbated by the increasing pressure due to the buildup of newly formed atoms. Lighter atoms, such as hydrogen and oxygen, would be more likely to form than heavier atoms and then, due to the lower density of water, travel outwards towards the crust. Over time, when the pressure buildup was too large and the stress on the body reached a critical level, the crust would rupture and crack and release particles, especially lighter elements, to the exterior of the planet. As a result, water built up would be released to the surface of the planet as the continents were pushed apart to a new stable volume of the body of Earth. This would lead to the Earth being in a balance with the production of mass by its electromagnetic field over time, as it would be larger and its released mass would be more closely equivalent to its produced mass, so that balance returned and expansion slowed to a crawl as it is seen today. This process would also lead to a substantially younger oceanic crustal age than the rest of the surface of the planet, which is what we observe. To get around this anomaly, plate tectonics claims all the evidence of the crustal age being the same as the age of the continental plates is hidden because the materials recycle into the earth, where the oceanic crust subducts under the continental plates. Therefore, according to plate tectonics, we only see new oceanic crust. Moreover, the question where the oceans of Earth came from is just as anomalous. With plate tectonics, it is necessary to ultimately assume they have just generally been there with no real explanation for how. Comets and other proposals exist, but do not provide a mechanism for how such a large amount of water would be present on Earth. The electromagnetic field of Earth produced the water by the convergence of flows of particles, leading to pressure buildup within the planet until it ruptured, breaking the continents apart and producing vast oceans. This explanation gives an answer not only to how the Earth expanded, but also where water came from and why the Earth is not presently expanding. As it matches what we see with our eyes, the general puzzle piece fitting capacity of the continents into a smaller globe, it means that this is a significant portion of the process for how the Earth became as it is today. And in conclusion, this chapter was meant as a short introduction to the explanations of several critical observations within the confines of the model. While there are countless observations to take into consideration, this process is ongoing, and the question becomes, at what point is a new opposing model taken seriously in science? How much sheer evidence needs to be presented along with logic and reason before the work of an individual can compete with the work of many across decades? Will this book be sufficient? Only time will tell. Alright, so thanks for listening to Chapter 5, and next chapter is Chapter 6, Applications in Society, and I'll be back with that. Thanks.